This is the application question of trigonometry. And firstly, we can find the given information here. Firstly, it is the angle DBE 30 degree, and then AB it is 60 cm, and AD it is 50 cm. And firstly, we need to find the length of DE. It means firstly we need to find this length, and from this graph we need to find this length. We have two choices. Firstly, we can focus on this triangle EDA. However, we have only one given information, so that it is difficult to find the answer, so that we forget these hints. And second, we can use this angle B E D, this triangle. We need to we have this information. We need to find this ED's length, but also we only have one information. So that do we forget this hints? Of course not, because we can find the answer. We can easily find out the length of DB through the angle of DAB. We know that it is 90 degrees, so that we can use Pythagoras theorem to find out DB first, so that we have this. It is Pythagoras theorem. Through the calculation, we can get dB is like that. Wait, 40 square, 60 square. It is square root of 6,100. We won't calculate the this uh, answer first, because we need to have the accurate data, so that we keep it in the square root. Then we have this one, so that if we want to find out this length, we can use tangent theta. Tangent 30 degree, it is equals to dE over dB, so that we have this one dE is equals to this one multiplying this one, and then we have the calculation. So that we can find the answer. dE is equals to 45.1 degree, 45.1 cm, and correct to three significant figure. If the question do not have any specific demand, we always use three significant figure to as the end to calculate the answers. And we just finished the question A, and now we are going to to do question B. Firstly, we mark down the answer first. This one, it is 45.1, and this is this one. Then we have a look at the question B. Question B need to find out the answer of DAE. So we can have a look here. DAE, it means this one. So this time we can draw it out. It is 90 degree D, A, E. We find out this one. And we have the answer, we already know the answer like that. And this is 50. We need to find this angle. So that we also use tangent theta, tangent angle EAD equals to 45.1 over 50. So that we also need to take the full answer from question A, so that we can find that angle EAD is around 42.0 degree, and we mark down here is 42.0 degree. And then for the question C, we also need to find out the angles. This time we need to find the angle AEB. AEB, it means this one. Here we draw out the triangle first. It is EAB. We have this 60 degree, 60 cm, and this one we don't know. We need to find this one, and we can easily calculate this too. Firstly, for the EA, we can focus on angle EDA, and firstly we find EA first. This angle EDA, we have this one 50 cm and this one 50.1, so that we can have a Pythagoras theorem to find out this one. Square plus 50 square, so that we have the answer of EA. It is have the calculation first. 25.1. And we have the answer around this one. As I mentioned before, we need to take the full answer of this one from question A, so that this answer it can be much more accurate. And we also need to find this EB, and for EB we can use this triangle to find. This is B, E, and D. We have this one, and then for this we have this one, and then we also use Pythagoras theorem to find this one. We have this one, and then we can find the answer is around this one. We have this one, so that we can use the cosine formula to find this answer. So we can write down the formula like this: EB square plus EA square minus 2 EB and EA, and cosine, we call this beta equals to 6t square, so that we can simply use this method to calculate the answer. Or second, we have the second method. We can see that it is a right angle, so that we have the second method. Firstly we have found we need to find this angle, and we have this and this uh, length. We know the length of this two, so that the second method is to use cosine beta equals to EB over the EA. Yes, cosine beta is okay. Or we can have third method to use the tangent beta. Tangent beta. We have the EA over the EB. And we have a different kind of method to calculate this kind of questions. I think you can try to use different method during the exercise so that you can find the most suitable one for yourself, so that you can calculate um, quickly during the examinations.